So Jonathan, you ready? Okay. Not now, no, but like today, yes. Okay, you guys, let's bring it in. Today, my hope is to show you a couple more things about VI or Vim. We're going to talk about predefined functions briefly. I know I talked a little bit about them last time, but I want to do a better job. And then we'll talk more in depth about user-defined functions. And then I will finish with a bit of a discussion about the bisection method and how to turn that into a function. And if I have time, I will even get into the whole default value thing. If you don't know what I'm talking about, don't worry. I'll talk about it in a minute. Any questions? Okay. Let's first talk a little bit about VI. When I'm writing a program, you'll often see me, let's see here, let me get into my examples and let me go into, say, this guy here. You'll often see me seem to compile it and run it from within VI itself. That's a pretty convenient thing to be able to do. So let me talk you through how to set that up. When you first log into the MATLAB, either using the terminal program or using PuTTY, your home directory generally looks something like this. In your home directory, you don't see them, but a standard Unix trick is to hide files that start with a period. So if I do something like ls-la or ls-a, that says show me everything in this directory. And you'll notice there's a lot more in this directory than just what I get by showing ls. By default, ls will hide files and directories that start with a period. This is an old Unix legacy kind of behavior that lets people put configuration stuff in files and directories that start with a period. This configuration stuff kind of controls how your environment behaves, but 9 times out of 10, you don't want to see any of that stuff. You just want to see the files that you're creating and using in your day-to-day work. One of those files is a Vim configuration file, .vimrc. RC, I can't remember, I think it stands for resource file or something like that. And lots of configuration files have that same general format. There's another one called tcshrc. There's one for me called mutrc that controls my mail program. So this is also a standard kind of Unix naming convention. What we want to do is we want to get in. You don't have to get into this vimrc, but let me open it up for you and just show you what it looks like. So this is just a massive collection of configuration commands for VI. And the one that I'm interested in, or the pair that I'm interested in, is ;G. Let me find it. Oops. Down here. Nope, down here. There we go. ;G, if I'm in command mode and I hit semicolon followed by a G, it will write the current file, that's what the W is, and then it will compile the current file. G++%, percent is a macro or an alias for whatever file you happen to be in. And if I hit ;R, it runs this partner command, it runs the a.out command from within VI. So when I'm up here and I'm writing these examples for you guys, I'm hitting semicolon G to compile, semicolon R to run. G stands for G++.
Do you have to save it or save automatically?
The way I have it written, it will save automatically because of that W right there. So if I'm in the file and I've made a change, I go into command mode, I hit semicolon G, it'll write the file and then it'll compile the file. Alright, if you want this vimrc, I've put it on the class web page. What you want to do is first, and this is a good practice whenever you're playing around with files, you want to move your original one out of the way. Typically when I'm moving a file out of the way, I will just rename it with the move command. MV means take this file and move it to the second file. And I'll often just append the current date so that I know when I did it. So now I don't have a vimrc anymore. And if I run vim right now, none of my configurations will load. What I'd like to do now is get the vimrc file from the class web page that I've put together for you. And there's another command called wget. Wget is just a command line way of copying something from the web into wherever you are. So if I do this, you'll see a little bit of gobbledygook. It's a very small file, so it downloads really quickly. You don't even see it. And it says .vimrc saved. Now if I ls my vimrcs, you'll see there's another one in there that I was playing around with this morning. But here's the one that here's my original one, the one that I renamed. Here's the one that I just got from the web. And if you look inside there, I've essentially just cleaned it up, removed lots of extra stuff, and somewhere down in there is semicolon G, semicolon R. If you follow these steps and then you go and edit a program, so here I am in the program. I'm in command mode, not in insert mode. So I'm in the mode where I can move around the cursor, but I can't type anything. If I hit semicolon G, not just sequentially, semicolon G, it'll compile. And if I hit semicolon run, again, not at the same time, but sequentially, semicolon R, it'll run. If I hit semicolon and wait, it won't do anything. So there's sort of a timing thing there. You have to hit them close enough together to make it work. So semicolon G, semicolon R. I'm never left it.
Oh, so it just sort of flashes to the other.
Yeah. So when I do semicolon run, it says enter value, and essentially this is sort of like being on the command line, and I can type some stuff. I don't even remember what this program does. So I enter a value, I run the program exits, and then it says press enter or type a command to continue. This is Vim talking to you. So I'll just hit enter, and I'm back in the editor. If I run the program and I decide I don't want to do anything, I just want to quit the program, I don't want to interact with it at all, I can hit Control-C, and that will break the program right there and then put me back into enter to get back to VI. Should save you a little bit of time if you're so inclined. Any questions about that? I can't remember if I showed you how to search. Did I ever show you how to search? I did? Slash? Double? Okay, let me show you something else. Suppose I want to change all the doubles to ints. So I can do search and replace, but I want to show you something else before I show you search and replace, which I'll probably show you next week. If I hit /double, remember that will find the first occurrence of the word double. How do I find the next occurrence really quickly? Does anybody know? Press N. Yes, very good. So if I hit N, I'm going to keep moving to the next one. The thing I want to show you today is something called the repeat operator, or the dot operator. So I'll find double, and then I can replace it. So I can say highlight it like this, and then I'll hit C for change, and then escape. Now if I find the next one and I want to do that again, I just hit period. And the next one, period. Next one, period. It's not quite as good as search and replace, but sometimes it's better. Sometimes you just want to see what you're doing, and this will let you do that. And of course, if you made a change by accident and you don't want to do that, you hit U for undo. The dot operator, you should play around with it. If you're doing something repetitive over and over and over again, play around with the dot operator, the period, and see if it repeats the way you want. It takes a little bit of getting used to, but it remembers pretty much everything from insert to escape, with a few exceptions.
So, can you go over that again? So you did /double to find the first occurrence of it,
and then N to find repeated occurrences.
And then you selected it.
And then I hit V to highlight it. And then I hit C to change it. And I typed what I wanted to change it to, and I hit escape. And then I hit N to go to the next double, and period. And now there aren't any more.
So, after you type in the change, then
Escape.
Escape, and then N, and then period.
Yep. So yeah, again, this is just one tiny example of what period can do for you, but know that it's there. It can save you some time. Okay, I'm going to talk about predefined functions now. Then I'll break and let Jonathan do his thing. Then I'll come back and we'll talk about user-defined functions, which is going to occupy the bulk of our time today. Let's look at some predefined functions. There are lots of situations where you might use predefined functions. Unfortunately, there aren't many available to us at this moment in time. So what I'm going to focus on is similar to what the book focuses on. I'm going to look at some of the math functions that are loaded by including CMath at the top. A predefined function is one that is provided to you by some third party. In this case, it's provided to you by CMath. And it's something that performs a task that you want to perform, but you have absolutely no idea how it does it. We do this kind of thing all the time in our modern lives. Somebody hands you a television and a remote, and you click on, right? You have no idea how pressing that button turns on that television set, but you do it. This is commonplace in programming as well. People provide third-party functions for solving linear systems of equations, for presenting graphics on a computer screen, and most of the people that use those functions have no idea how they work internally. They just read the instructions on how to use the function and then incorporate it into their program. A simple example of that is something like the POW function. Let's see, double x equals 3, double y equals 2.5, and cout POW 3 2.5. This will print out 3 to the 2.5, whatever that happens to be. So I'll hit semicolon G to compile this thing, hit semicolon R to run it, and I get something that probably is in the ballpark. I have no idea how PAL works internally. I mean, I have some idea how it works, but you get my drift. I didn't write PAL. And this is a real issue, especially numerical analysis, because sometimes people will write predefined functions, give them off to other people, and they don't behave quite the way that the user wants. And then it's up to you to try to figure out how to fix that problem. So with a third-party function or a predefined function, we have to read about how to use it. So, for example, you can go to the web. It's a great resource for pretty much anything having to do with computer science, and search, for example, for PAL and C++. And often the C++.com website comes up, which is a really beautiful site for just general C++ standard references. So I pop that up, and here is a description of the PAL function. So it tells us how it works, returns the base raised to the power exponent. It has this long list of stuff up here, which I'll talk about in a bit. The base is some floating point value. The exponent is some floating point value. So it's describing the arguments. How many arguments does this function have? It has two arguments. It also describes the return value. This is what is given back to the user when the user calls the function. So the result of raising base to power exponent. And then there are some caveats about errors that can occur. And then we have an example down here of how it's used. This is a pretty standard approach to documenting a predefined or third-party function. And you can imagine they get far more complicated. Later in the semester, we're going to use a package called Open Frameworks for doing graphical kinds of programs. Open Frameworks is a whole collection of third-party C++ functions. And the only way that we're going to learn how to use them is by reading about how they behave. So you go to the documentation and you see all of these functions, and you click on one of them, and it says, okay, here are the arguments. It tells you how the thing behaves, and if you're lucky, it'll give you an example. We don't really know how it works internally. We just trust that the developers have written good documentation and that we can use it, safely. You look at the power function. You look at square root. You look at cosine. You know, if I asked you to compute the cosine of some number, write a function that computes the cosine of some number, what would you do? I mean, in your program, what are you going to do? Right? I hand you a number and I want the cosine back. How do you do that? Because all you have by default is plus, minus, multiplication, division, and maybe a couple of the other default operators. So that's one approach, and in fact, that's a common approach. Let me see if I can find. So the series is one approach. It turns out that that's sort of the first level approach. Gosh, I think it's called the codic. I can't remember. I can't remember. Cosine algorithm. Quartic. There it is. Quartic. as you can imagine, people have studied this problem really, really hard to make this as efficient as absolutely possible. Because if you have a program that's taking cosine a lot, you want it to happen as quickly as possible. You can read about this Cordic coordinate rotation digital computer, whatever that means. You can read about this algorithm. Cosine is often computed this way, and it has little or no resemblance to anything you know about cosine or sine. In fact, it gets down to the level of manipulating bits in a floating point number. This possibly is somebody's doctoral thesis, computing cosine really efficiently in a computer. One of the really nice things about some of these algorithms is they can actually be built right into the hardware. You can actually build circuits that compute these cosines and sines and other complex mathematical formulas. That said, if you were really pressed, and if I was pressed, I would use a series. I would just expand sine or cosine out in a Taylor series to an appropriate number of terms to reduce the error. Why is that a good thing? Because if you expand something out in a Taylor series and you chop it off, what's left is this polynomial. Polynomials can be evaluated by the 4 basic operations of addition, subtraction, multiplication, and division. Go ahead, Jeff.
So what do you mean by built into the hardware? What is this function in the hardware?
Yeah, so I can create a little rectangular piece of circuitry, and over here there are a bunch of switches, and I can set those switches to the input value, and then I can turn a crank or light up the voltage, and over here these switches will be the output value for cosine. And internally you have these logical circuits that go through algorithms like this to spit out the correct cosine. All right. Why don't we pause there, let Jonathan do his thing, and then we'll come back and do user-defined functions. Are you going to use the computer?
Yeah, I'll need the projector.
Okay.
Can I have it?
You can.
Alright. Alright.
I thought it was Jonathan going today. Farley. Oh, Farley's the old one. Farley was still logged in. Sorry about that.
That's fine.
No, I'm sorry to Jonathan. Sorry to
Yeah.
Chris.
That too.
Trust me, I didn't send any terrible emails on your behalf.
Okay, so sorry I've lost my voice a little bit, so I'll just do the best I can. But this was kind of the article I read in Wikipedia, of course, to get my information.
What's the topic?
Net neutrality.
Net neutrality.
So what is net neutrality? It's the principle that internet service providers, such as like Comcast, Verizon, AT&T, and governments should treat all data on the internet equally. So this basically means that internet service providers should not discriminate or charge differently based on the user, the content, the site, or any application you're using. And net neutrality advocates want to ensure that everyone has equal access to the internet, so they kind of see it as a fundamental right, and that no one is given preferential treatment. So why is it needed? Currently, I listened to a podcast by this woman, Susan Crawford. She worked in the Obama administration for the last 4 years, and she believes that due to the massive amounts of deregulation in the telecom industry, that many of these telecom companies are operating as a monopoly, and they're able to do so by tiered services, so that they're able to control the pipeline of data, remove competition, and create artificial scarcity. So a tiered service would be you go to AT&T and you can pay a different amount for a different number of minutes or data or texts. The idea being that the more you pay, the faster your internet's going to be. And also, she talked about in the podcast, it's actually quite interesting, about in 2002 and 2005, the FCC, the Federal Communications Commission, decided not to extend common carrier rules to cable companies and dropped line sharing rule for DSL service. So basically what happened was that plummeted the number of internet service providers by 74%. of those companies. So it's created kind of a lack of competition in the industry. And due to this lack of competition, advocates of net neutrality believe that these telecom companies may purposely degrade network performance for some users, or even block certain kinds of content. So, for example, this is already done today a little bit. So if you have a Verizon or AT&T phone, I'm sure many of you do, and you have an unlimited plan for data, if you ever pass like 4 or 5 gigabytes, they will purposely slow down your data without you knowing it. So that's a form of of a telecom company kind of taking advantage of the user. Opponents, it's very much a political issue. So opponents of net neutrality argue that the best solution is to encourage greater competition, not to regulate the industry more. And they also, I have a comic about net neutrality. It's not very funny, but it kind of shows what the argument is for it. They're kind of proponents of net neutrality, kind of arguing for net neutrality as access to the internet as a fundamental right, that no one should be denied access to the internet due to a lack of funds, or I don't know if you can read it, but yeah. So you shouldn't. They don't like companies discriminating basically on income or how much they're able to pay. So if you're not able to pay a certain amount, you're not allowed to get data, or possibly not even enough minutes for your phone. And that's basically it. So why are the companies doing it? Is they're doing it basically as cost-saving measures, and also to create artificial scarcity to keep prices high. That's what at least net neutrality advocates are arguing. And I'm sure that in the next few years we'll be seeing more about it in the political scene.
Questions? So a classic example here, just to really drive your point home, would be if Verizon, which is one of the major internet service providers in the country, decides to start a streaming service. And then they purposely degrade the Netflix streams into their network so that they're practically unusable. Well,
yeah.
Where are you going to go? You're going to go, either going to have to go to
Verizon. Or a very common thing is that they won't provide service to people that live, in like in rural areas or something, or way out in the country. They won't, because the lines are too expensive to get there, so they won't offer them internet service, or if they do, it'd be for some ridiculous price that no one could afford.
Right.
So these net neutrality proponents want to ensure that everyone has access.
That's definitely part of net neutrality, but I think that the closer analogy, or the thing that people are really worried about, is providing preferential treatment.
Yeah, slowing down data and
or slowing down data to prop up the ISP's business model for some other area.
Yeah, so a big company pays a lot of money, they want to have the fastest data, so they'll reallocate data from us or to them or whatever.
There was a telecom in Canada several years ago where the workers went on strike, and the telecom happened to be the ISP as well, and they actually blocked access to the union website. So, and there's really nothing in current law that prevents ISPs from doing that kind of explicit censorship.
Yeah, they could just block everything today. There's no law against it, so that's kind of.
I guess you can kind of tell which side I fall on.
Yeah.
Any other questions?
Yeah. So I know how spectrum is distributed, and the FCC regulates that. There was a bidding war for that, but how do you become an ISP?
Yeah. So there are these massive trunk lines that run across the country, and they're owned by a few very big players in the industry. Essentially, there are laws that force large infrastructure owners to rent at reasonable costs to smaller providers. So a local provider in town here is Pocket iNet. Has anybody heard of them? Yeah. Pocket iNet is, at best, is a regional ISP. They certainly don't own the pipes that, say, get from Walla Walla to Seattle, but they use them. And essentially, it's not even that they're renting per se. It's not that they're renting. They're just sort of paying for access to those pipes. So that's kind of how it works. And then as you get really big, like if Pocket INET gets big in a few places, maybe they'll pay and they'll connect a couple of their larger regions together with some of their own pipe. It's a long and expensive process.
It's very expensive. There's a lot of entry barriers too.
Yeah. We are pretty bad at doing broadband in this country. Right?
Yeah, compared to other countries like, I think she said South Korea, where they have just as fiber. I don't remember exactly, some type of wiring, copper wiring or something that's like 10 times faster and cheaper, and they don't do that because there's no incentive for these companies to do it, really, because it's really expensive. But, you had a question?
Yeah. Is anybody against this, like, for the companies other than the companies?
Yeah, there's a lot of it's very much, like I said, a political issue, and the problem with net neutrality, I suppose, could be it'd be further, the government imposing itself further on companies and forcing them to do things that possibly they wouldn't do, in the free marketplace. But yeah, there's a lot of people against it. I actually watched a couple of videos, this one guy, I forget his name. He's a conservative, of course, a conservative comedian. He talked about how net neutrality would be super bad for the companies. It'd be also super bad for the users. So it'd be something interesting to watch. I could email you his name if you wanted. But yeah, there's definitely a large contingent of people against it and for it.
All right, thank you. You're very predictable, Sarah. Wasn't really a compliment per se. Yes. Okay. Let's go on to user-defined functions here. So there's a specific syntax that we want to go through. Let me remind you of the first user-defined function that we created, which was on Monday. This is a really, really simple example of a user-defined function. In a sense, this is a classic calculus kind of function. It takes a single input and produces a single output. So in this case, the function that I defined was just x squared. When I define it, I have to give it the name. I have to tell C++ what's the name. In this case, it's the simple name f. I have to tell it what kinds of things are going into it, how many arguments does it have, and what data types are those arguments. And I have to tell it what's going to be returned to the user of this function. And then I have to define what the function does. In this case, the function takes its single argument, multiplies it by itself, and returns it to the user. This is what we call an inline function. I'll show you in a minute how C++ actually more typically separates the declaration of a function and the definition of a function. The only time that you would have the function created like this would be in a very simple case like a classic Calc1 function. Let's do a slightly more complicated one so that I can show you what's a more typical usage of user-defined functions. So what I'd like to do is build a function that tests whether a particular character is a letter or not a letter. So what does it mean to be a letter? It means that I'm either lowercase a through z or I'm uppercase a through z. Anything else, so if I test one of those characters, this function is going to return true. Otherwise, it's going to return false. So there are two steps generically speaking, to defining a C++ function. The first step is the declaration. And here you give the name, number, type, arguments, and the return type. And typically you also include a comment about how to use it. So let me define my letter test function. I'm just going to call it isLetter. And this will return true if its character argument is a letter and false otherwise. So if this thing is returning true or returning false, then its return type is what? Boolean. Good. I'm going to name it. I can name it whatever I want within the naming conventions of C++. So I'm going to call it isLetter. And it takes a single argument of what type? Character. That is enough. That statement right there is enough to declare the function. At this point, that's all it does. It doesn't explain how to actually accomplish this task. It just says that, hey, compiler, if you're going through my main program and you run into something that says isLetter, make sure it has one argument and that it's of type character, and also make sure it's in a place where Boolean makes sense. That's all it does. So it's really just to help the compiler with syntax errors, to let you know that you're not using this particular function correctly. Declarations usually occur, in fact, they have to occur before the function is actually used in your program. Just like a variable, right? A variable has to be declared before you can use it. A function has to be declared before you can use it. The slight difference is here, typically the function is declared above the main function, whereas variables are usually declared inside the main function. And there are exceptions to both of those cases, but let's just stick with the general rules so far, and we'll talk about those details later in the semester. Below, we define the function. And it looks a lot like the declaration, at least to start with. It's bool, it's the name, it's the argument type, but now we have to introduce a dummy variable, which I'll call C. So above, it's not necessary to provide a dummy variable because, again, this is a syntactical construction, just letting the compiler know what the context is for this particular function. But below, when we want to define the innards of the function, we actually have to have something to work on, something to act on. And so we provide a dummy variable. In this case, I'll call it C. And when you use this function, C is replaced by whatever input you happen to be using at that point in the program. All right, let's talk about the innards here. So now we're back. We're not thinking about functions anymore. We're just thinking about how can we write a C++ program to do what I want it to do. Detect whether C is a letter between A and Z, either upper or lowercase. Ideas. Yeah?
Could you use the ASCII values?
Yes. So let me Let me pull up another terminal here. Here, to do this program, we're going to see another useful feature of the ASCII character set. I want you to focus on the capital A in the upper right-hand corner and notice that its decimal equivalent is 65. Then B is 66, all the way down to Z, which is 90. These guys are consecutive in the ASCII table, and that's really important. Why? I can define an interval. More.
I have no idea.
So I have this character in my hand. It's a character, so it certainly has some code associated with it. How do I know it's between A and Z? Yeah, it's just a simple Boolean expression. Are you bigger than 65? Are you less than or equal to 90? Right? Okay. Okay, so I made a few adjustments to your suggestion. C is the character that I'm testing. I come in and I put C here, C greater than or equal to the character A. What's going to happen? Is it going to be an error? So it's not a syntax error. It clearly runs. It clearly compiles. Does it make sense? Is there some way to make sense of that inequality from the computer's perspective? We talked a little bit about this before, about how integers and characters kind of interchange and interact. That's what's going on here. What do you think is going to happen when the program gets to this inequality?
Just go skip the second part? Like if it satisfies C is greater than equal to A, or just skip the C is less than equal to Z?
Well, I want to step one step further back and ask, how does it even do that? The C greater than or equal to A.
Isn't that what the isLetter command is for?
Yeah.
Doesn't it just take the C, convert it to the integer, take the A, convert it to the integer? Has that.
That's either true or false. And then, yes, that's exactly what happens. So there's no, I mean, you can think about alphabetical comparisons, right? But that's not what's happening here. It's not that it understands alphabetical order. What it does is it converts the C to its ASCII number, it converts the A to its ASCII number, and compares the numbers. That makes sense, right? You can compare numbers. Okay, if it's bigger than A, great, but you also have to be less than Z in order to land in this range, and that's what the double and is. So these both have to be true in order for the whole thing to be true. Because if you look at the ASCII table, there are characters that are bigger than A, but that are not less than Z. For example, left square bracket will be bigger than A, but not less than Z. Yes.
So don't we need to include another interval typology?
Yeah. So I was going to let us discover that by accident, but preemptively, what if I do lowercase d? What's going to happen here? It's outside the range. In fact, lowercase d, if you look at the table somewhere, there we go. if you look at the table, lowercase d is 100, and that's bigger than uppercase Z as a number, so it's not going to fall within that range. So how can we also allow for lowercase letters? How can we modify this Boolean expression? Or
Are the lowercase letters directly after the uppercase letters?
there's a little gap. See?
Oh, yeah.
I suppose we should group these. I think and has higher precedence than or, so it's not a problem. But if you have doubt, go ahead and group. So if C is within the capital A to Z range, or C is within the little a to little z range, return true, otherwise return false. Let's see if this compiles first. So I hit semicolon G. Everything is lovely. Let's go up and try to use it. Yeah, thank you. I do that a lot. Okay, enter a character, M. M is a letter. F. F is a letter. Capital F. Capital F is a letter. 1. 1 is not a letter. Minus. Minus is not a letter. You get the idea.
What is that? If command if is letter
Okay, so
is that
you tell me, what's going on with if is letter M?
Testing whether or not M is a letter. M is a character of that.
So I get M from the user, and I need to know, what is it? Is it a letter or not a letter? I just wrote a function that does that. The function takes one character argument, right? So I take that character and I shove it in there, and that thing will turn into true if it's a letter, otherwise it'll turn into false. And that's what we use to trigger if statements, right? So if this turns into true, then the top part will happen. If it turns into false, the bottom part will happen. Yeah?
So the order doesn't matter. Like you can put the if else you just did above. You can.
Yeah. So it's interesting. The function is defined down here. It's declared up there, and it's used in here. And it's important to. You're not going to get it today. Some of you who are more comfortable with this stuff or have used this stuff before will get it today. But a lot of you are going to have to think hard about this. There are 3 different things going on here. There's the declaration of the function. There's the definition of the function. How does it work? And then there's the implementation or using of the function here.
So is letter, that's the function that we're defining, that's not a pre-existing command.
I just made it right here.
Yeah, okay.
So it gets to the first if else and doesn't recognize it, so it skips it, and then once it reads in the definition.
Okay, are you talking about the compiler now?
Yeah.
So the compiler comes along and it says, oh, is letter with a character argument is okay. So it gets down to here and it sees this and says is letter, and then it looks at this and says, oh yeah, That's a character. So this is good. I'm going to give it a pass. And it keeps on going, and it turns it into machine code. Then it gets down here, and it turns this into machine code. And the two, it's sort of, they're two separate pieces. There's the main function, which maybe looks like this, and then there's the isLetter function that looks like this. And right before it turns it into a.out, it takes this piece and glues them together like this and creates a fully functioning a.out. And that's a step that you don't have to deal with. So it is not necessary to define the innards of the function before you use it in main. It's simply the case that you declare it. You can define it later, and then the compiler will take care of getting this thing into the right place. It's very counterintuitive from what you normally have done so far. Yes?
Do you have to, that last part, can you put that anywhere, or does it have to be where you
This guy can go, you know what, I haven't played around with it too much. I know for a fact that it can go up here. I know for a fact that I can put it here. I suspect, oops, not make. I suspect that I can even do it in reverse. But I'm just guessing. I think I can even do this. Oops. Yes. Really counterintuitive. That's because of behind the scenes, the way this thing works is main is like one puzzle piece. And this thing is like another puzzle piece. And in order to get a fully functioning program, it takes those two puzzle pieces and puts them together. Watch what happens if I leave it out. It says there's an undefined reference to isLetter character. And that's the compiler's way of saying you're missing a puzzle piece to create a fully functioning program. You haven't told me how to do isLetter. You've declared it, great, but you haven't told me how to implement it, how to do it. Let me show you what happens if I make a typo here. So if I make a typo, it says isLet was not declared in this scope because I didn't define it. Notice I don't get that error if I change this to an R and I get rid of this guy. I don't get an undeclared thing. What I get is an undefined reference to isLetter character. Different errors. Very subtle stuff, not something that you really need to focus on at this point. Other questions? Yeah.
So could you have put the int main before the declaration?
No. Let me just move this guy. I take it back. Maybe. No. So you're not going to go wrong, at least at this stage in the semester, of declaring the thing at the top, writing your main program, and putting your function definitions at the bottom. That's straight up standard C++, and that's what I want you to focus on. On Friday, we'll talk about the details of the bisection method.
Is the assignment due Friday?
No, it's due Monday.